Okay, so let's talk about bolted connections now. The current version of Eurocode 3.14 only covers the design of bearing type bolted connections, in which the bolt is made of austenitic or duplex stainless steel. Slip resistant connections are not covered in the current version, but they will be included in the next one. So generally speaking, the resistance of stainless steel bearing type connections can be determined using the same resistance equations that are given in Eurocode 3.18 for carbon steel. The only difference is on the bearing resistance of the plate, which for stainless steel is based on a reduced ultimate tensile strength, which is in order to account for the more pronounced nonlinearity of stainless steel. Now, an important consideration when selecting the stainless steel bolting assembly is that the bolt, the nut, and the washer should all have better corrosion resistance than the connected plates. And this is because of the geometry of the connection, which make it more susceptible to corrosion issues. And a typical example is the additional corrosion you might have at the connection due to the crevices in the connection. Now, another important consideration is to take into account the risk of galling, which might happen when tightening the bolted connection. So galling is basically a form of addition wear that might happen between the threads of the bolt and the nut due to friction. And in some extreme situations, might even cause sizing of the threads. So galling might also lead to premature failure of the bolt because of the increased twisting force that is introduced when trying to overcome the increased friction between the threads. Now, although galling can also happen in carbon steel assemblies, bolting assemblies, it is more likely to occur with stainless steel bolting assemblies. But fortunately, there are a series of measures that you can follow and that will minimize the risk of galling. So for example, you have decreasing the tightening speed, making sure the threads are as smooth as possible, and making sure the threads are lubricated. That's very, very important to prevent galling. Preloaded bolt. So as I mentioned previously, Eurocode 3.14 does not cover the design of preloaded bolts. And because of this, both the installation procedure and the resistance have to be determined from test. Now, rules for calculating the slip resistance of preloaded bolts will be included in the next version of Eurocode 3.14. And these rules are basically the result of a European project which has demonstrated that austenitic and duplex stainless steel bolts can be satisfactorily preloaded, providing the correct bolt grade, tightening method, and lubricant are used. So this European research also showed that stainless steel bolting assemblies experience a similar loss in preload than carbon steel bolting assemblies, and that when the fairing surfaces are prepared using agreed plastic media, it is possible to achieve slip coefficients that are equal or even greater than 0.4, which is pretty good for a slip resistant connection. Okay, so this slide is showing a bolted connection between stainless steel and carbon steel material. In this figure, the carbon steel plate is left unpainted, And basically what the figure is trying to show is bimetallic corrosion, which might happen when the carbon steel material is in direct contact with the stainless steel material. Now, there are a series of factors that need to be present in order for bimetallic corrosion to happen. So first, you need to have two dissimilar metals with different electrical potential. So in this case, it would be the stainless steel and the carbon steel. Also, you need these two dissimilar metals have to be in direct contact with each other. And there have to be an electrolyte solution as well, bridging the stainless steel and carbon steel material. So this electrolyte solution could be any liquid that conduct electricity, like, for example, seawater, impure fresh water, rainwater, condensation, etc. So what will happen in this case is that a current will flow through the electrolyte solution from the carbon steel material to the stainless steel material. And the carbon steel will corrode at a faster rate than if the stainless steel was not there. The rate at which the carbon steel will corrode will depend on several factors, one of which is how electrically conductive the electrolyte solution is. So because of this, when creating a voltage connection between carbon steel and stainless steel, you need to consider the risk of bimetallic corrosion and take measures depending on the conditions that are expected for the connection. So here I'm showing you two options for preventing bimetallic corrosion depending on the type of connection you need to design. With both options, what you're basically doing is prevent the direct contact between the dissimilar metals. So if the connection is a bearing type connection, you can prevent the direct contact by using insulating bushings, washers, and gasket between the dissimilar metals. Now, one important thing to consider with this type of solution is to make sure that the bushing is able to maintain its integrity at the ultimate limit state when the bolt is bearing against the plate. For slip-resistant connections, this solution would not be suitable because the washers and gasket are made of compressible material, which will affect the preload applied to the bolt. So because of this, for slip critical connections, you will need to use the option we have here on the right, in which the carbon steel material is painted with a waterproof coating.